Okay, today we're going to start or continue with our study of trig functions. These are all identities sitting here that you will need to know. Some of them you really have a good grasp at this point. We've said that cosecant is the reciprocal of sine. So if it's the reciprocal of sine, you're going to get 1 over sine theta. Secant is the reciprocal of cosine, which would be 1 over cosine. Cotangent, the reciprocal of tangent, 1 over tangent. We also have our quotient identities, and tangent we have identified as y over x. So please remember that y is represented by the sine of theta, x is represented by the cosine of theta. So therefore we have sine theta over cosine theta. Cotangent is represented with x over y, and again cosine is the x value, sine is the y. We do have our Pythagorean theorems, and these are based off of an xy pair here. So if you're kind of thinking of just in a coordinate plane, there's your triangle, there's theta. We have said that cosine represents the horizontal, sine represents the vertical. Our hypotenuse is 1 if we're dealing in a unit circle. Based off the Pythagorean theorem, because we do have a right triangle here, a squared plus b squared would equal c squared, which would leave us with sine squared theta plus cosine squared theta is equal to 1. If you can commit these to memory, these other two Pythagorean identities can be derived from it. So let's say I take this one here, and I divide everything through by cosine squared theta. If I do that, sine squared theta over cosine squared theta would get us tan theta. Cosine squared theta divided by cosine squared theta would get you 1, and 1 over cosine squared theta would get you secant. If, on the other hand, I divided by sine squared theta, sine squared over sine squared would get you 1. Cosine over sine squared would get you cotangent. It's fine that they're reversed. Remember that addition is commutative. And 1 over sine squared theta would get you secant squared theta. So that's how these two came about, and they're derived by dividing by either sine squared theta or cosine squared theta. For our even odd properties, I want you to think about theta being in quadrant 1. Okay, so let's say that's theta. And then we have negative theta being in quadrant 4, because negative would show just the direction in which it turns. So what you got out here is an xy pair. Down here, your x would be positive, your y would be negative. So if you move from quadrant 1 to quadrant 4, and the item that we're talking about, so let's say I'm talking about the sine of negative theta is equal to negative sine theta. If it was positive in 1 and negative in 4, the negative here moves out to the front. And because cosecant's part of the sine family, the same thing happens. If you think about your cosine family, as I move from quadrant 1 over to quadrant 4, the x stays the same sign, so therefore I just call it being absorbed, like the negative gets absorbed, because the cosine theta value would be the same whether the x value was in 1 or in 4. For tangent, again, because that's y over x, or in cotangent's case, x over y, in quadrant 1, y over x is positive. In quadrant 2, it's going to be negative y over x, so it's negative. So again, you have a sign change, and if there's a sign change, that negative gets pulled out to the front. Now, we can use these properties in order to find the exact value of an expression. I'm just going to show you one, because it's really easier just to do it the way we've been doing it. I could, because it's sine, pull the negative out front. I would then say to myself, what is the sine of 30 degrees? That coordinate is root 3 over 2, 1/2. So that negative would be there, and we say negative 1/2. However, I really do think it's easier. Just go to where the angle is, negative 30. We show the direction this way. Now the coordinate's root 3 over 2, negative 1/2. Sine is y. So I'm just going to go through these the way that we have been doing it, not necessarily employ the even odd properties. We'll use them on the back page. If I'm looking for the cosecant of, let's say here, let's just change colors here, the cosecant of negative 45 degrees, so that's over here. So our coordinates are root 2 over 2, negative root 2 over 2. Cosecant is associated with sine, so it's going to be 1 over negative root 2 over 2, which becomes negative 2 over root 2, which once rationalized becomes negative 2 root 2 over 2, and finally we're going to land at negative root 2. If I think about the cosine of negative 2 pi over 3, because there's a 3 in the denominator, the semicircle's being cut into 3 equal pieces, the negative showing we're rotating this way, so 1, 2 is going to put me here. That would leave a 60-degree angle over there, which means the y value here is going to be root 3 over 2 negative, and then the sign is going to be negative 1/2. So if I'm looking for the cosine value here, cosine is represented by x, so our answer would be negative 1/2. If I look at tangent of negative pi over 6, that puts us right over here with a 30-degree angle. Across from the 30 degree is the 1/2, vertical is represented by sine. So we're going to have negative 1/2 and then root 3 over 2. If I'm looking for tangent, it's y over x. So it's negative 1 over half over root 3 over 2. These guys cancel, leaving us with negative 1 over root 3, and then rationalized. Okay, so let's flip our papers over to the other side. We want to use some properties of the trig functions in order to evaluate this. For the most part, you're going to have to show work in order to gain any credit. This one here is one where work doesn't necessarily have to be shown. So let's just think about for a minute the Pythagorean identity on the front page. Tan squared theta plus 1 is equal to secant squared theta. In algebra, we can add and subtract anything to an equation so long as what we do to one side we do to the other. There's nothing to stop me from subtracting tan squared theta from both sides. In that case, I now get 1 is equal to secant squared theta minus tan squared theta, which is what we're looking at here. Secant squared minus tan squared, theta in this case happens to be 37. In order to do these identities, you do need to get the degrees the same. We don't have to do anything in this case. They're already the same, as where no work needs to be shown. And this is an understood identity of just subtracting tangent over, so the value of this would be 1. If I look at problem number 6, the first thing I notice is that the degrees are different. So I want to get a coterminal degree with 380, which means I can subtract 360 degrees from here. So first step I'm going to show, I'm subtracting out, giving me a coterminal angle. That would be 60, it would be 20. So the cosecant of 20 degrees times the sine of 20 degrees. But cosecant is 1 over the sine of 20 degrees times the sine of 20 degrees. These would cancel up, and again, we'd wind up with 1. Now, if you just give us 1 without showing these steps, you will not be getting the problem correct, because the value is in showing us how you get there. So these odd-even rules are going to be taken into consideration here. Secant is part of the cosine family, and like we said, when we move from quadrant 1 to 4, the x values change. So therefore, that negative is going to be absorbed. So this is going to be the secant of pi over 18. I also notice here that obviously my angle values are not the same. Because the semicircle's being cut up 18 times from here to here, it'd be a total of 36 to go the full circle. So I can subtract 36 pi over 18 there, which would get me the cosine also of pi over 18. But secant's really 1 over the cosine of pi over 18 times the cosine of pi over 18. These guys cancel, and again we are left with 1. Now let's try these other two here. They're all the same degree measure, so I don't have to worry about that. I do know that sine over cosine is the same thing as tangent, so this becomes tangent of 20 degrees minus tangent of 20 degrees. When you subtract something from itself, you get left with 0. Let's look over here. First thing, I'm just going to look at the angles. They're both pi over 12, so that's great. 1 over secant squared is the same as cosine. So this is really sine squared of pi over 12 plus cosine squared of pi over 12, which is that very first Pythagorean theorem that says sine squared theta plus cosine squared theta is equal to 1. So this guy here would also equal to 1. We're going to get some more exact values. We said last class, we talked about coterminal and periodic functions. Right here, they're telling me the sine of theta is 6 over 7. I want to know what is the cosecant of theta plus 4 pi. Well, 4 pi is just 2 rotations around the circle. So that would leave me at the same place as the cosecant of theta. So these guys are coterminal with each other. Because cosecant is the reciprocal of sine, the answer here is going to be 7 over 6. If I look at 11, it tells me the cosine of theta is equal to negative 3 over 7. I want to find the exact value of 5 times the cosine of negative theta. And again, as you think about moving from quadrant 1 to 4, the x values remain positive, so that negative is going to be absorbed. So the first thing I'm going to show is that. So this is really the same as 5 times the cosine of theta. And they're telling me cosine theta is negative 3 over 7. So the exact value is going to be negative 15 over 7. Let's just scoot this guy up a little bit here. Given that tan theta is equal to 2/3, find the cotangent of negative theta. So for cotangent, again, as you move from 1 to 4, there is a sign change, so we're going to pull that negative out, so you need to show that there. Cotangent is the reciprocal of the tangent of theta, so this is going to be negative 3 over 2. This one's not asking us to evaluate, it's asking us to simplify. Sine theta, that negative would be pulled out front, so we're going to get negative sine of 3 pi over 10. I'm also noticing that my angles are different. So cosecant, because each semicircle is being split 10 times, it would take 20 pieces to get all the way around. So I could subtract 20 pi over 10 out of there, leaving me with 3 pi over 10. But cosecant is really the same thing as 1 over sine. So this is going to be times 1 over the sine of 3 pi over 10. These guys cancel out. Don't lose this little negative here. So our answer for this guy would be negative 1. And we just have 2 more evaluating problems to work on. It's telling me, okay, if the cotangent of theta is negative 3, find the exact value. For tangent, as we move again from quadrant 1 to 4, there is a sign change, so that negative gets pulled out in front. And we know that cotangent of theta is actually equal to negative 3. So we're going to replace cotangent of theta with negative 3, getting us a value of just 3. Alright, so let's look at this one here. We did talk last lesson about how tangent is periodic every half circle. And again, that's because you have a plus plus situation here and a negative negative. So as we move from quadrant 1 to quadrant 4, we remain with positive tangents. So you are periodic whether it's a full turn or a half turn. So the first thing I'm going to do is change all these to be to the coterminal angle, which are all cotangent theta. There's a total of 3 of them here. So it's going to be 3 times cotangent theta. And we were told cotangent theta is negative 3. So our exact value here is negative 9. Okay, and with that, we're concluding 5.3. And we'll be preparing for the quiz of 5.1 through 5.3 for the next class.